All right, boys and girls, so we finished the multiplication unit. We've done two things with multiplication. What were they? Nice and loudly, please.
Order of operations and multiplication algorithm.
Yeah, you got half of it. The order of operations was a separate thing. That's working with expressions and equations. But in multiplication, we used the standard multiplication algorithm, but we also did something else. Sammy? Let's keep going here. Josh?
Estimated.
You estimated. Okay? That will be the same, that will hold true the same here. Except there's a word up here which I didn't really use that much when we did multiplication, especially the estimation part. What word up here looks, well, I wouldn't say foreign, but is a word that I just haven't used all that much. Yes?
Compatible.
Yes. What does the word compatible mean? What does the word compatible mean? Yes.
Easy to use, like compatible numbers, like 10 times 10 would be compatible numbers. Easy.
Let's use, say, this example of 10 multiplied by 30, or 10 by 10, or 10 by 50. Those are compatible numbers because they are what? There's a word, they are either R or they are S. They're kind of, when things are compatible, you know, my wife and I are pretty compatible, okay? Because, yeah.
Like,
Close. 2 and 8, 2, 4, 8, 12, 6, 14 are all what?
Reason.
What kind of numbers
Related.
are they? That's it. Good. All right. How are 2, 8, 6, 12, 14 related? They are all what?
the basic multiplication.
They're all what? They're all even numbers. All even numbers. Compatible numbers are somehow related with one another. They are simple. And we are going to be working with the standard division algorithm. Okay? So there's going to be a way that we work with division that's very similar to the way that we work in multiplication. Okay? So here's what I want to do today. We're going to do breaking down numbers. Very important for mental math. Okay? We're going to do a couple of division models. And we're going to work very simply today with a 1-digit and a 3-digit division problem. Except we're going to do two things with it. What are we going to do? One more time. What are we going to do? We're using the and the good. We're going to estimate a quotient, and we are going to use the algorithm. All right, boys and girls, I just gave you a little over 30 seconds to come up with ways we see multiplication in the world around us. So, why don't we even start in this room? Where do we see multiplication? Yes.
On the board.
On the board. Wow. Okay, Xavier, he's funny. Where do we see it in the world around us? Well, for the one thing, the first thing is we see it on the smartphone. Okay, that's a good joke. Very nice. Right. Very entertaining. Thank you, Xavier. Yes.
Stock exchange.
Stock exchange. Right? Okay. That's a no. Stock market. Where else?
Multiplication table.
Yeah, the times tables. Okay. That's right there with being up on the smartboard. Where else in the world? Come on. Absolutely. Okay. Yes. When you pay, good, making payments. That's definitely where your parents use that, for sure. Sammy? Taxes? Somewhere else too. I mean, I go there once a week. My wife gives me this huge list. Come on, she goes, Jim, you better get this or else you're in trouble. You're grounded. Yes. Supermarket. Okay, so it's all relevant, it's all around us, but if multiplication is around us, then so is division. Okay? So let's start with this. I'm going to give you a problem. Okay, ready? There are 71 donuts. There are, let's see, there are 4 classes. And Mrs. Pemberton wants all 4 of these classes to get an equal number of donuts. So, there are 2 parts to this question. The first part is, how many donuts will each class get? Could somebody tell me what the second part is going to be? Judging by the number 71 and 4, what's the second part to my question? Second part to my question. James?
How many times can 4 fit in the 71?
That's the process. But it's a different question we're looking for here. It's a good try.
Is how many donuts
Will be left. Now, in the standard division algorithm, the word won't be left, but that ends up being your remainder. So, I want you to solve this right now using any method you know. All right, so what did you do? Tell me what you did. Yes, loud please.
71 divided by 4.
Okay, so I'm going to bring up a new sheet here, and I'm going to write it a couple of different ways. 71 divided by 4. Now you notice I'm not using the division symbol as you used to use it in the past. We need to get used to this. Okay? 71 divided by 4. I just want to make sure we understand this, because what does this say? Right. And that, as we all know, is completely incorrect. I'm showing this to you because you may be getting a sentence that says, what is 163 divided by 27? And you got to take that sentence, that word problem, and convert it into a number sentence, which is this. Okay? So here we are. I could also use a standard division algorithm. There's a house. What goes inside? Yes. And then what goes over here to the left? At the entrance to the house.
4.
A 4. Thank you. And of course, what goes up here? The answer. Okay. Now these have names, and we're going to get to that. But let's see what you already know. What is the number inside the house? The big number. The one that you break up into equal pieces. Large.
71.
Yes, but what is it called? It's called something. That number is called something. This number is called something. And the answer is called something. What is that? Yes.
Inside the house, it's called the dividend.
Okay, dividend.
And the 4 is the divisor.
Good.
And the answer is the
Okay? Alright. So, in your head, this is a division problem, but what are we using to do the division problem? I mentioned this kind of last week. I thought it was kind of funny. But when you're using the algorithm to do a division problem, most of the steps involve what skill?
multiplication.
Multiplication. So can you tell me what you're saying in your head right now? Because I'm hoping you were thinking of your times tables. I gave you a simple problem. What were you saying in your head? Don't give me the answer. Just tell me what you were saying in your head. And these little silly questions will be very helpful when you get a big problem to do.
How many times does 4 go into 7?
Okay, so let's translate how many times does 4 go into 7. Let's translate that into a number sentence. Give myself a little more room here. And I'm saying to myself, here's a 4, here's a 7, and here's my question mark. And this is what I'm saying. Division is actually multiplication. Okay? And you're asking yourself that. So you're doing the times tables. Let's do it. 4 times 1. Very good. I started off easy on a Monday morning. 4 times 2. Uh-oh. What does that mean, boys and girls? Tanya? There it is. So let's go back up to the standard algorithm. Okay? Move up here a little bit. And I'm going to take my 1, and I'm going to put it, you should have hopefully learned this last year, but we're still going over it, up here. And then what do we do? Let's see if you remember stuff from last year before we do the real screencast. This is just a review. Yes?
4 times 1,
You're multiplying the 1 by the 4, yeah.
and then you put 4 is 7,
Good. Then what do?
and then you put
Excellent. And you get, we have a bit of a mess here, but that's okay. You guys actually remember a good amount from last year, which is really good. And what's 7 minus 4? Somebody else. Somebody else. Yes.
3.
Thank you. And what comes next?
Bring down the 1.
Bring down that 1. And now we're still working with the algorithm, okay? And what are we doing? What are we asking ourselves now? What are we asking ourselves now? Cameron? How? Yeah. Well, let's be a little more specific. Sammy? Not just a 3? 31. All right, so he's putting it in a question form just like this. Okay? Just like this. Except what Sammy is saying now, 4 times what number, question mark, equals 31. Again, multiplication to solve our problem. So, 4 times what number? What is 4 times 5? 4 times 9. 4 times 9.
36.
All right, can't do that. 4 times 8. That's got to work.
32.
That doesn't work either. All right, what is it going to be?
It has to be something.
Good. Okay, so 4 times 7 is 28, which means that there is going to be a remainder. All right, so let's move this out of the way once again. And complete this problem. 4 goes into 31, we said, 7 times. And now what do we multiply? What do we multiply? All I should be up here. What do we multiply? Say?
4 times
4 times 7
Good.
equals 28, and subtract it from the 31. And then you get 3, and that's the remainder.
And then I put an R here and next to it.
13.
How many of you think we're right?
Yes.
Okay, does anybody remember, from last year, how you check a division problem? Because actually, if I gave you a quiz, I don't have to grade it. You could grade it yourself. You actually have the answer key to a test like this, and you don't even know. Imagine that. Anyway,
Wasn't it like multiplication or addition?
it could be, possibly. How do I check the word? Josh? So, let's just look at this. If this is the divisor, and this is the dividend, and that's the answer, 4 divided by 71, right? I'm sorry, 71 divided by 4 equals 17. Well, let's check it. What is 17 times 4? We're multiplying, because he was right. With 1. 4 times 7 is 28. Let's see how you guys did. I'm checking the work. 4 times 1 is 4. Plus 2 is 6. Now, I see a 68 here, and it's 71 here. What do I still need to do? That's not right. What do I need to do? Yes.
You need to add your remainder.
Let's add the remainder, which is the number 3. And so 68 plus 3 is 71. And now, on the right side of your sheet of paper, you check your work. You see a 71. You see a 71 in the dividend. And you know, for a fact, your answer is correct. So we've kind of done a review of what you learned last year right now. And I think that's a great start.